Okay, reciprocal identities. So we're going to zoom in a little bit. Reciprocal identities just means what is flipped over what. So sine is actually 1 over cosecant theta. Oops, wrong way. Okay, so sine is 1 over cosecant. So then cosine is 1 over secant. Okay, and then tangent is 1 over cotangent. Let's make sure that's correct. Yep, that's correct. This is in your book on page 302. Cosecant. So cosecant is going to be 1 over sine theta. And then secant is going to be 1 divided by cosine of theta. Now it's actually more important to understand the secant, cosecant, and cotangent, but you can always flip between these. And then this is going to be 1 over tangent of theta. Okay. That's reciprocal identities. Quotient identities. So tangent and cotangent are made up of quotients. That is, it is, whoa, what just happened? Sorry. I don't know what just took place. Okay. Sine of theta, and that's going to be divided by cosine of theta. Okay, that's tangent. Okay, and cotangent is going to be cosine of theta, and that's going to be divided by sine of theta. Okay, so you need to keep track of these. These are going to be useful for later. Now there's 3 Pythagorean identities. We will cover these in more detail as we go, but they're useful. So there's sine of theta plus cosine squared of theta. So sine squared theta plus cosine squared theta, and that is just going to equal 1. Now the rest of them are actually built off of this. So what we're going to see is the next one is if you divided everything by, I believe, cosine, yes. So it's 1 plus tangent squared theta equals secant theta. And then instead of that second case, we have a third case that's going to be built if you divide it by sine. So you get 1 plus cotangent squared theta equals cosecant squared theta. Now I want you to note something. I'm going to put this, I want you to note something. That sine squared theta is the same thing as if you put in parentheses sine theta squared. Okay? That's an important note. Okay? Sorry, zoom in a little bit. So here's our reciprocal. You can copy them down. Here's our quotient. You can copy them down. Here's our Pythagorean. You can copy them down. I'll give you a second to do so. Okay. Okay, let's look at example 4-5. So if we get an angle, let's take this back to normal. Okay, if we get an angle such that sine of theta equals 0.6. Now, that's going to be that doesn't tell us the angle, right? But we have a few trig identities that are useful. 0.6. Sorry if there's not a clear dot there. Okay, we have sine of theta, sine squared theta, plus cosine squared theta equals 1. Well, what's 0.6 squared plus cosine squared theta? Get it equal. This is going to be 0.36 plus cosine squared theta equals 1. Subtract 0.36 from both sides, and you get cosine squared theta equals 0.64, and then you square root both sides, you get cosine of theta equals 0.8. Okay, well, you have sine and cosine. How do you find tangent? Well, tangent, we have the quotient rule, which is tangent theta equals sine theta over cosine theta. So, tangent theta equals, substituting in 0.6 for sine and 0.8 for cosine, we get tangent theta equals 3 over 4. Okay, or better yet, 0.75. Okay, that is using those identities. There's one extra problem here. Oof, got something stuck in my nose. Okay, you can work on that one. Tangent theta equals 3. They have cotangent and secant. One of them you're going to use trig identity. The other you're going to use reciprocal. Okay, so let's look at some application. So that's angle of elevation, which is if you had a line. My apologies. If you had a line and you're looking up, angle of elevation is going to be this theta, okay? This is angle of elevation. Now, angle of depression is if you were looking down. So, angle of depression.
Oh, that's sad.
Yeah, that's why we don't look down. Okay, and then these both will be our horizontal. They treat the same way. And these are our observer is right here or right here, and this is object. So object. This is observer. Okay, so angle of elevation, they give us our horizontal. We have to solve for our vertical. Yeah. The next one is they give us the angle. It's not really angle of depression, but you can treat it like that. They give us the vertical and hypotenuse, so we have to find horizontal. And then same thing, we have opposite angle, and we want to find hypotenuse. So let's solve these out. Okay, first one, we have, they give us the x and the angle. So this is 78.3 degrees, and this is 115 feet. We have to find y. So, what's the thing that's going to have or adjacent and our opposite. That's going to be tangent of 78.3 degrees is going to equal y divided by 115. Multiply this out, we get 115 times tan of 78.3 equals y. And I solve that out, plug that into a calculator. Next one is going to be, so they give us they ask us to find for theta, they give us, actually they don't ask us to find for theta. They give us the opposite and hypotenuse, and they want us to find adjacent, right here. Well, you could just use Pythagorean theorem, so 200 squared plus x squared equals 400 squared, and then you can solve this out, okay? Pretty simple one. Or, if you're solving for the angle, which you can, you're gonna get, you wanna find, what is it? Oh, okay, so they ask us to find the angle based on this. So we go sine of theta equals opposite over hypotenuse. Opposite over hypotenuse, sine of theta equals 1/2. Which angle of theta will we get? This is one of our special triangles. Hint, it's probably one of the ones we covered just earlier. And if you got it, it's 30 degrees. Okay? The last one, you're just going to solve it for the basic sine. I'll just show you. They give us skateboard ramp. So this is 4 feet. C, and this is 18.4 degrees. So we get sine of 18.4 degrees equals 4 divided by c. So we get c equals 4 over sine of 18.4. And then you plug it into a calculator. And that is going to be it for class today. I will see you guys shortly. We will talk at 11:30. See you then. Bye.